Compounding interest is actually an example of a geometric sequence when we multiply by the same thing each time. And what we're multiplying by is called a common ratio. So that 1 plus I, or whatever, that we're multiplying the principal by each time is considered our common ratio. It's what we're multiplying by each time. So let's look at geometric sequences. So this is a geometric sequence, 1, 3, 9. We're multiplying by 3 each time. So the next one would be a 27, then an 81, then a times 3, that's a 243, I believe. What am I multiplying by each time here? Well, this would be by a half. So the next one would be a half, and then a fourth, and then an eighth. 3, negative 6, 12. Oh, this one's multiplying by a negative 2 each time. So I'd have negative 24, then a positive 48, then a negative 96. So here's kind of a formula for finding any term of a geometric sequence. We're going to take the first term times the common ratio to the n minus 1. So we want to find the seventh term when the first term is 5 and the common ratio is negative 2. Again, you could write out all of them if you wanted. I'm too lazy. So a sub 5 equals the first term is 5, the common ratio is negative 2, and then we're going to the n minus 1, so that would be to the fourth power. So negative 2 to the fourth power would actually be, that says seventh term, doesn't it? Oh my goodness. I am just not with it. Seventh. I just said 7 and I wrote a 5 again. I'm hooked on 5s. So this would be to the sixth power. So I would just literally take my calculator and make sure you put your parentheses right. 5 parentheses negative 2 to the seventh power. Oh, sixth power. Oh, I'll get it right sooner or later. And we get a 320. Ooh, a ball is dropped from a height of 125 feet. If it rebounds 3/5 of its height each time it hits the ground, how high will it bounce after it strikes the ground for the 5th time? Well, maybe I was thinking about this problem, because the 5th time would be a sub 5. Started off at 125 feet, and it's getting 3/5 of its height each time, and this would be to the 4th power. (16.2 feet). Wait a minute. We needed a sub 1. This is a sub 0. This is like the initial, like before it even fell. I apologize. I just thought about that. So a sub 1 would be after the first bounce, so that would be 3/5 of it. Wow. I should try waking up today. Sorry guys, I hope I'm more awake when we get back to school. I knew something didn't look right. Let's try that again. At least it goes to show you that teachers can make mistakes and not read the problem carefully as well. This is in feet. Just like arithmetic sequences, we can find the sum of a geometric sequence, and we're given a formula for that. So we don't have to memorize anything. These are formulas that you'll be able to pull back in your notes. The sum is found by taking the first term times 1 minus the ratio to the nth power divided by 1 minus the ratio. So find the sum of the first 5 terms. If the first term is 4 and the common ratio is a -3. So we have to be really careful with this one, even when we put it in the calculator, because it's a -3 to the nth. Okay, so that would be to the 5th, because we're doing the first 5 terms, over 1 minus a -3. I highly suggest just typing it into your calculator just like that. I know some of you like to do things on your own, and I just messed up. I forgot to close my parentheses. So that's why it's always good to close your parentheses on your paper, because you'll make sure you do it in the calculator. 1 minus a -3. And it's 244. Could you have also written out the 5 terms and added them up? You could have. But I wouldn't want to do that. Alright, I'm missing the terms here. Oh my goodness. Okay, so I know my first term is 1/4, and we're multiplying by 1/2 each time. So the sum of the first 6 terms, I would take 1/4 times 1 minus, oh, that should be a 1. 1, we're making it a 1, minus 1/2 to the 6th power over 1 minus 1/2. Gosh. And I get 0.492, basically. Now, let's see if this one actually is a fraction. It is 63 over 128. Either answer would work. The reason I'm changing it back to a fraction is because that problem had fractions in it.